Well, good morning and welcome to our 25th Annual Capital Conference Virtual Edition. My name is David Trussell, Director of STEM Activities for UIL. This session is on calculator applications, an analysis of the 2021 state meet test. And with us as our presenter today is Dr. Dave Bourell, our longtime state director for the calculator applications contest. And so we're very glad that you're here, very glad that Dr. Bourell is here. And I will turn it over to him.
Great. Thanks a lot, David. I appreciate it. And also thanks to everyone for taking the time to come be part of this session today. There was what I thought was an excellent question that was already posted in the chat box, which was, is there a way that we can get the test I'm going to be talking about accessible to everyone? And I don't know what the answer to that question is. Really, I'm deferring this to David. But maybe during the talk, if it's okay with the UIL office to release that test, David, I just emailed you the test and the solution. So if there's a way to get it, I don't know if there's a way in Zoom to get that posted so people can access it or download it. I'll leave that to you to try and work. And if you need to jump in, feel free to jump in to make that work. Okay.
All right. Let me take a look at that, and I'll see if we can get that to happen here.
Super. Thanks very much. I guess the other thing too, folks, is as far as the feedback or questions during the presentation, if you have questions, I think the plan is at the end of this presentation, which hopefully won't take anywhere close to the full hour, you'll have an opportunity to unmute and we can have some discussion. Rather than, I think that's preferable to using the chat box for you to type in questions, although you're certainly welcome to do that at any point during the presentation. I'm hoping maybe David can monitor those. And if it's something that's cogent and would be best answered on the fly, just interrupt the presentation and we'll take care of that. That won't bother me at all. So, but at any rate, that's where we are. So with that introduction, then let me just jump right in here and see if I can get this screen share going. Hopefully you can see the presentation here. Should be the cover slide for the talk, which is what's not supposed to be scaling stated problems, that's for sure. So that's obviously not the right presentation. So let me see if I can find the right presentation here. Capital Conference. We want to do some test analysis. Let's see. Well, let's see. Well, it says scaling stated. I guess it's the right presentation with the wrong title. So let's just jump through here and hopefully it will turn itself into the right thing. What I wanted to do, first of all, let me say something. First of all, let me mention to you, some of you, I decided not to use the background. I'm sitting in my home in our guest room, which is filled with nutcrackers behind me. And we call this guest room the Nutcracker Suite. So I'm coming to you live from the Nutcracker Suite in beautiful South Austin, Texas. The state meet this year, as many of you know, was conducted virtually, and there were a number of ways to do that. But we had a reasonable complement of contestants, 123, and you see the breakdown here. It basically was 20 contestants from each conference. So, 123 students took that test, and it was turns out that it's actually quite unique, we'll get into this. Just so you know, this is the way that the test administration worked. The schools had, had options to test a score within a group of schools. There were a number of things there. I'm assuming you're familiar with those. The test what you may not be familiar with is what happened after the test was taken. The tests were scanned and sent to the UIL. I received those 123 tests for grading electronically. As far as the grading was concerned, what I did is I identified 13 coaches who were able and willing to grade the test. It was done remotely by Zoom. We basically had a Zoom meeting just like this one, and I sent the test out, emailed the test to the coaches or to the graders, along with an Excel spreadsheet that was effectively a grade sheet. There were 70 columns to enter the results for each test on every problem. And so as usual, the graders were coaches of the winning teams. We emailed those tests to them with an Excel spreadsheet, grade sheet. So the graders didn't really mark the test. Rather, what they did is they entered the status of each problem into the Excel spreadsheet. There were, if you're familiar with the contest, there are 4 ways to answer that you can mark a result on the test. It's either correct or incorrect, but it could be an SD error on the 2 SD problems, the significant digit problems, as well as it could also be blank, where the difference between blank and blank by my definition is those are the problems towards the end where the contestants simply didn't get to. So for example, if a contestant only worked through problem 55, I would consider problem 56 through 70 to be blank. So that's what I mean when I say blank. If they skipped a problem, number 7, if they skipped that one, which was there was no answer in that answer blank, I don't call that blank, I call it incorrect, because according to the rules of the contest, if you skip a problem, even if you don't attempt to work it, we still exact the penalty for as if it were incorrect. And again, that's just the standard rules of the contest. Okay, so the grade sheet, one of the nice things is the grade sheet, actually, I was quite happy. I put together an Excel formula to calculate the grade, and it seemed to work pretty well. In terms of doing calculating the scores, which I thought was kind of nice as well. So what happened is once the grading was done, the coaches would, obviously I sent, for every test that came in, I sent it to multiple graders. So I think we triple graded all the tests. And so to make sure that there were no inconsistencies, that, to try and make sure that we had an accurate grading of the test. Once that was done, the graders sent me the tests back, emailed them back to me. And I basically compiled those results into this master Excel document, calculated the places. Now the deal here is I didn't realize this till afterwards, but there's actually, in my opinion, maybe it may not be valuable to you. I hope you'll find it meaningful. But this is really sort of a unique treasure trove of information that I have, because for the first time in 40 years of this contest, and actually almost 40 years of me working with the contest, for the very first time, we have at our disposal a very rich compilation of data, because I know how every single student who competed at the state meeting calculator did on every single problem on the test. So, it gives an opportunity to check some of our assumptions about the test, as we'll see as I go through this talk. So here's some of the analysis. So as I mentioned here, again, it was a rare opportunity to do some analysis. And again, let me acknowledge the obvious. What we're looking at is I'm going to be making some general statements about the calculator applications contest based on this one test. So it's sort of, I'm kind of making some generalizations based on a data point of 1 in some sense. So for example, what we're going to find is I was a little surprised that students at the state meet had more trouble than I thought they would have had on problem number 18. So I don't think it may not be fair to assume that problem 18 on every single contest is a difficult problem. It just turned out that was, just the luck of the draw this time. Maybe I put a problem there that was a little harder than I think maybe should have been. And we'll see that as we go through do the analysis. But by and large, I think, we could follow some general trends that at least were largely consistent with my thinking about what the contest should be. The other thing that I'd like to emphasize as well for everybody from the beginning here is that the way I write this contest, I do 9 tests a year. I do, I believe I do 5 for the UIL and 4 for the Texas Math and Science Coaches Association. And all of those tests, one of my goals in preparing those tests is for all of them to have the same level of difficulty. So, you don't want to think, okay, well, test A, the invitational meet release test that I do for earlier release, that those are going to be, say, easy, and that, the district test will be a little harder and the regional test harder still. And I'm really going to save all the hard problems for the state meet test. That's not the way it works at all. It never has been the case. What I do is I sit down and I literally write 9 problems of a certain type, and then I literally randomly disperse those onto the test. We could easily exchange test A with test I. That is an invitational meet test with the state meet test, and there would really be no difference in terms of the nature of the difficulty of the test. So I think the reason I mentioned that is because the conclusions that I draw based on analyzing the state meat test are going to be probably, I would think for the most part, would be generally applicable to any calculator test that I write. So anyway, for what it's worth. Okay, so again, there's 4 ways to answer a problem. If it's correct, they get +5 points. If it's incorrect or skipped, it's -2 points. Again, I think most of you already know this. After the last problem attempted, all those blanks between the last problem attempted and problem number 70 gets 0 points. I call those are going to be the blanks. And then of course I have the right number with the wrong number of significant digits, which on problems 27 and I think it's 37 on this test. So those get +3 points. So these are the 4 ways we can address a problem. Okay. So now here's the first. We're going to be looking at a lot of plots that look like this. So let me spend a little bit of time and help you understand what I'm doing here. What this shows is the numbers 1 through 9. Let's just concentrate on number 1 there, the far left side. What this is how those 123 contestants at the state meet this year, how they handled problem number 1. So this the first problem on the test, it's a number cruncher, as you well know. And what you see are 6 bars here. And I think most of you have figured out by now that those 6 bars are by conference. So for problem number 1, if you look at this in conference 1A, the blue line, 100% of the contestants at the state meet, all 19 or 20 of them, every single person worked problem number 1 correctly. Again, I perhaps expected that would be the case. It was only, however, for conference 2A, it was only 85%. If you do the math, if there's the number stats people, if you have nominally 20 students that are in conference 2A, 85%, that's basically 3 out of 20 that missed it. So basically there were 3 people in conference 2A that either skipped problem number 1 or more likely worked it incorrectly. 100% of the people in conference 3A worked it correctly. There was 1 person, 5% represents 1 person in conference 4A, the yellow bar, that worked it incorrectly. And 2 people in conference 5A worked it incorrectly, and 1 person in conference 6A worked it incorrectly. So basically you got, on average, just looking at the line here, probably 90, 95%, somewhere in there, people worked that problem correctly. Okay, so now you can sort of, we go a little bit faster now, having worked through that one case. Looking at problems 1 through 10 as a whole, what you can see is that for the most part, contestants were very successful working all of those problems, including the stated problems, which are 6, 7, and 8, and the 2 geometry problems 9 and 10. That's relatively heartening. I think most of us coaches, certainly most of the coaches I've ever talked to across the decades, have said that, page 1, there should be no reason why a reasonably prepared contestant should be able to work all of those correctly. And I think based on this, I would say, well, maybe we're doing pretty well there. I'm reasonably happy with this. So what I'm going to do now is I'm going to look through the other 6 pages. So this is page 1. Let's go to page 2 and see what it looks like. Okay, so here's page 2. So we see, looking at problems 11 through 15, which are more number crunchers. Again, one could argue, okay, more people have missed these, but again, for the most part, it's most of the people are getting it right. I mean, so some people are missing them, but for the most part, I would say I don't see anything that particularly concerns me about the first 5 problems. Problems 16, 17, and 18 are the stated problems. And I was a little bit surprised here. This was my first surprise that on page 2, that those problems would be such that we would have, significant number of people missing those problems, which from my perspective, for example, makes me think, well, maybe I'm getting too difficult too quickly on those stated problems going into page 2, particularly problem 18 that I've alluded to already. You see there that I would say the average there is probably 50 or 60% of the people got it correct, which I would think should be maybe, if I were designing the test by perceived number of people getting it correct, I would think that for page 2, it should be more like 80% should be getting it correct. So this gives me pause. I'm doing a little bit of soul searching. Again, at some point during this presentation, I'd love to hear what your comments or feelings are on this with what you see here. The other thing that you can notice, not so much on problem 16 and a little bit on problem 17 and perhaps most strongly on problem 18, is there seems to be a conference effect on the performance on the problems, where the 1A typically tends to be on the lower side, and the 6A the students from 6A schools tend to do better. And again, I'd like to hear your comments about that if you have perceptions about that. It very well could be the the number of the types of courses that are offered in math and the exposure students are able to get. Again, I'm unfortunately not an expert on that. Y'all are the experts in terms of what's going on in the school, so I completely defer to you on that. Problem 19 and 20 are right triangle problems. Students pretty much got those correctly, as you can see, which is also heartening. Okay, let's jump on to page 3. Here's page 3. Again, you look at the first 5 problems, people typically tend to do very well on those. Again, I would say maybe 90% of the students at the state meet last year got those correct. Problem 26, 27, and 28 are the word problems. And by the way, what I try and do on the first 4 pages of this contest is I try to go from very easy problems to very difficult problems. So in fact, I've told people that if I were to ask to say where the most difficult problems on the test are, they're typically the stated problems on page 4, and the stated problems on page 3, namely problems 26, 27, and 28, would be the next group of next hardest problems. And again, in this case, I think that I think that the student responses tend to, I think, sort of correlate with my thinking of what that should be. I mean, I would think that maybe if I were going to sort of dictate what student success would be, I would think by the time we get to these hard stated problems on page 3 that maybe it would be reasonable that maybe half the students would get them correct, and that's sort of where we are here. Maybe we're closer to 40% on this one. But again, there still seems to be this trend on problem 26, 27, and 28, where there seems to be this conference sensitivity from conference 1A to conference 6A, perhaps most strongly noted on problem number 26, that shows the success. So for example, just in case you're not following, if you look at problem 26, what I'm saying is from conference 1A, 30% of the students got that problem correct, whereas 90% of the 6A students got it correct, right? And then it tends to trend between conferences as we go. Problems 29 and 30 are solid geometry problems. They're completely random. And by the way, problem 26, 27, and 28, I typically will try and go from easier to more difficult within those 3. It looks like I've been successful, at least on this test, in terms of the test. However, on problems 29 and 30 are absolutely completely random. So the fact that 85% of the contestants got problem 29 right, and it looks like maybe only 30 or 35% got number 30 correct, that's just completely random. That's not done by intent. Those problems again are random in terms of the level of difficulty. So that was just the luck of the draw this time. Okay, well, jumping on to here's page 4. As we see that, again, you look at the number crunchers, people typically do pretty well on the number crunchers, problem 31 through 35. 36, 37, 38 are, if my intent was to make these problems difficult, I would say I succeeded. We have, I would say probably maybe 25% of the contestants that got 37 and 36 and 37 got it correct, right? So these obviously were successfully very difficult problems. Looking at problem 38, I think I may have overdone it a little bit on that problem, because in this case, looking at it's only 5% of the students in 5A and 6A. Basically, that means there were 2 students, one in conference 5A and one in conference 6A, of the 123 students at the contest that worked that problem correctly. So I think, in my opinion, as I look at this, my conclusion is, well, maybe problem 38 was a little too difficult. So on the other hand, I mean, everybody has the same test to look at. So, I don't think this has a direct impact necessarily on who wins the contest. But I think what it says to me is that maybe that problem was too hard. It as well, I mean, you have to appreciate, I write, the number crunchers, when I do the test generation for the contest, and again, this is just me. This isn't really applied to any of y'all. But you have to appreciate when I do these contests, I'm writing 9 tests. So it's like 315 stated in geometry problems I sit down to write. The number crunchers are all computer generated with using C++ programs that I wrote 20 years ago. And they generate pretty well. But the ones that I have to sit down and handwrite, take a reasonable amount of time. And, if I sit down and, it's sort of, for me personally, it's kind of discouraging a little bit. And it's completely my fault that, that I write a problem like problem 38 that nobody can work, because I spend time writing it. And it's like, gosh, wow, a lot of people didn't even look at it. Kind of makes me a little bit depressed. Going on to problem 39 and 40, 39, I believe, is a circle in a triangle or a circle outside a triangle. There's some formulas that you use for that. And I say contestants did pretty well with that. Problem 40 is the law of sines or law of cosines problem. And people seem to have maybe a little more difficulty with that, as you can see on the test. Okay, going on, here's page 5. Again, these are the people that worked the problem correctly. Again, the first 5 problems are all the number crunchers. Again, the people did those pretty well. Problem 46, I went ahead and listed for you over here the type of problem to help me, actually primarily to help me remember. Problem 46 was a scaling problem, and that was a very difficult problem, apparently. I don't think of scaling problems as being necessarily intrinsically difficult, but I think this one may have been a hard one. And again, if David was successful getting you the test, we can maybe you can look at it. I have the test at the end of this presentation, and we can go back and look at any of these problems. If you want to note a problem, at the worst case scenario, we can look at it at the end of this presentation. So
Dave, I did post links to the test and key in the chat box, so people can pull up the test there.
Excellent. Thanks very much. Yeah, so feel free to do that. And if you want to take a look at a particular problem, we can do that. And certainly we can talk about it collectively at the end of this session. So anyway, so here we go. So problem 46, the scaling problem, was a hard one. Again, my run on this is I think that it was just a hard problem. I don't think it was intrinsically scaling principles that was the difficult part. I think it was the problem itself was a fairly difficult problem. Problem 47 was using the sum plus feature of the calculator. So it's sort of a linear regression type problem. And again, if I were predicting, I would have predicted more students would have worked that successfully, because it's, for the most part, it's sort of entering a bunch of XY data and then doing a interpolation or extrapolation, which I thought was fairly, if not routine, was a fairly straightforward technique. But again, I'm really very interested in hearing what your thoughts are on these, that you're the ones that are really in the trenches. I'm up in the ivory tower. Anyways, that was a little surprising to me. Problem 46, I think, was reasonable in terms of it was just a hard problem. This one I don't think was particularly difficult, and still only about 50% of the contestants got it correctly. Problem 48 is an iteration problem. These are typically transcendental equations or equations that are really difficult to solve, like maybe an equation that has a variable to the 5th or 7th power, things like that. And I would say that that most students should do that. Basically, the procedure is pretty much uniform. It doesn't take a lot of thinking, at least I don't think. At least when I work the problems, they don't seem to do that. Basically, you enter the equation in the calculator and hit the solve button. And depending on which calculator you're on, you fairly quickly or maybe serendipitously can wind up with an answer in just a matter of seconds. So, and people did pretty well on that. So I was happy with that. Problems 49 and 50 are sort of solid geometry problems that are typically more complicated. So they're multiple step problems that using solid geometry. And again, I guess, problem 49 must have been a difficult problem. Again, these are completely randomly placed on the test. So in this case, problem 50 seems to be a little easier than problem 49. But I would say that maybe, 1 in 8 worked it correctly. And again, we're on page 5, and these are difficult problems. I guess I'm that seems to be, not totally out of reason that we would be at that stage. Okay, a problem, going to problem, to page 6, again, looking at there seems to be a little bit of tail off on the first 5 problems. We'll talk about that in a little bit, but people typically do the number crunchers pretty well. Problem 56, I was actually, to be honest with you, I was quite encouraged by the fact that seemed to be 25 or 30% of the contestants actually worked that problem correctly. This is what I call a calculus basics problem. It's a problem that would, say, come out of a high school math book from a calculus course. So it's basically, here's an equation, what's the derivative at a point, or do an integration over this area. It's, there's no real life analysis here, a real life scenario. It's just completely mathematics. Problem 57, as you see, was another one of the very difficult problems. Only 2 people worked it correctly at the state meet. And this is what I call a calculus applications problem. So here it's real life examples where the verbiage on this problem is some real world example where calculus is needed to solve the problem. And obviously, this takes a significantly higher level of learning and mastery to be able to work successfully than simply taking the derivative of an equation or integrating it or finding a maximum or minimum, which is what happens with problem 56. So again, I would say in this case, I would say I was successful in gleaning a problem that problem 57, which was more difficult by virtue of requiring a higher level of knowledge and mastery of the subject. But again, I'm thinking, when only 2 people at the state meet out of 123 worked correctly, maybe I overdid it in terms of the level of complexity for this test. So, that's again going to be part of my soul searching, for the next year. Problem 58 is a matrix problem. Again, there are about 50% of the contestants worked that problem correctly. I would have personally, if I were betting with it before I saw this, I would have bet that it would have been closer to 80 or 90% of the contestants, simply because these are relatively, again, it's not a real high level of thinking. It's basically knowing how to do some very basic matrix addition and multiplication, and maybe know how to do determinants of 2x2 and 3x3 matrices. So it's just learning some of the basic rules. It seems to me that students would be able to do that. So, and again, everything I'm doing is hopefully by now is complete speculation on my part, because I'm the first to confess I don't know what goes on in the high school classroom, and I don't know what goes on as you prepare students to compete in this contest. But anyway, I would have thought that would have those problems. Basically, when I get to problem 58, I go, okay, this is going to be an easy one to work because. But again, I know the matrix algebra, which takes me to my first rule of higher education, which is everything's easy if you know how to do it. But at any rate, going on to problem 59. Problem 59 is a calculus problem, and it typically tends to be difficult. I would have predicted that maybe 20% would have gotten that one correctly, and students typically did better on that problem than I thought they would have. So because it's typically a fairly complex calculus problem on the geometry side for problem 69. Problem 59. Problem 60 is typically just a very difficult plane strain geometry problem, and that seems to have worked. It looks like maybe about 10% of the contestants got that correct. So again, I wonder about that one, whether it's too difficult. Okay, so if you bear with me for one more page, here's page 7. You have to appreciate now that the number crunches are at the end of the test, right? So let's look at 66 through 70. What you see here is that for 66 through 70, only about 60% of the contestants work those problems correctly. If you look at those problems on the test, you'll see that they're not particularly difficult. So this is one of the shortcomings of just looking at the number of correct answers, because I speculate that the large number of people who didn't work these problems chose not to work it, not because those problems were too difficult, but rather they made a strategic decision to stop working the contest before problem number 70. Right. So as a matter of fact, those of you who are coaches who coach this test, it may not come as a surprise to you that there were a significant number of students who stopped at problem number 55. So, and they don't even look at the rest of the last 15 problems. So it turns out that because of that, particularly for problems at the end of the test, looking at who worked it correctly, or how many people got it right, it's really not a very good measure of how difficult the problem is. And I just want to own that up. Now, if you go to page 1 or page 2, I think the number of people working the problem correctly is a fairly good indicator, but not here at the end of the test, again, because of the fact that people make a strategic decision on where to stop working problems. Okay, well, having said that, if you look at problem 61 through 65, I think this comes really as no surprise. Problem 61 is typically a sort of a page 4 style, very difficult uh, uh, word problem. And you can see here that I was successful in making it that way. We're down at probably 5 to 10% of the students got it correct. So again, when we're down at that lower range, it makes me wonder if the problems are too difficult. Problem 62 is a log solution. It's a very straightforward problem to solve. It's a very straightforward technique. And in fact, some of the calculators may even actually do the simple calculation directly without having to use the log solution approach. And you see here that students typically work that problem correctly. I'd say we're talking probably 55% of the students got it right. If I were, sort of speculating on what that would be, I would think that would be higher. Again, simply because the technique is relatively fast and it's relatively straightforward. Once you can get to the equation, which is typically very easy to do, it's about 4 steps to get to an answer. And those 4 steps are the same 4 steps for every single problem. So I would think that would be one where maybe students could maybe do better on. Problem 63 is a trajectory problem, and again, it was relatively difficult, and you see that. 64 and 65 are hard plain geometry problems, and I was successful in making those really hard. Although again, you have to appreciate that these may not be as hard as they look here by virtue of the fact that people have stopped working the contest by now. Right. So this is a combination. Basically, the people that did not get those problems correct is a mixture of both students who thought it was too hard or opted not to work it, having looked at it, and students who just made a strategic decision to stop working at problem 55 and not even look at it. We'll get to that in a second. Okay, so that gets us through the 7 pages of the test. Now let me at this stage, now that you've gone through mono, I'm going to go through the test again in stereo here. And let me talk about what we're looking at now. What I'm looking at is I went back through the contest, and let's look at the top set of lines. So basically, what the top is the percent of people who wrote something in the answer blank. So this is going to take away the people who skipped the problem. So I want to know how many people actually tried to work the problem. So I went back and looked at that. And so basically to try and get your grips around what what the implication of this top one is basically for me, I look at the top and go, if everybody worked the problem, that makes me feel good because basically I spend time writing that problem and people actually tried to work it, so it means that there was at least some hope that the problem was worth looking at. So I think of the top as really kind of most interest to me, but maybe of interest to you as well. What the bottom series of lines is the percent of people who wrote something in the answer blank, didn't skip it, and who worked it correctly. So I think this bottom line might be the one that might be of more interest to you, because it says if you have a contestant that actually worked the problem, what's the chance they actually got it right? Okay, so if looking at page 1, the first on the first page, there were only I count maybe 4 people. There were 4 people in the room who opted not to work, who skipped one problem on page 1. Of the 123 contestants, basically everybody worked every problem on page 1 except for 4 people on one problem each, right? So that, from my perspective, I'm going, that's pretty good. I like that. That's the way we would anticipate. And in looking at the bottom, most of the people that wrote those that entered an answer actually got it right. So that makes me feel pretty good too. Okay, looking at page 2, problem 18. there's really not much that's really noteworthy other than problem 18 here. And you can take a look at that if you downloaded the test, or we'll look at it in a minute. But what we have here is people, not many people worked it, but if you look down at the bottom curve set of lines, most of the people that worked it actually worked it correctly. So I'm not sure what conclusion to draw from that, other than the people that tried to work it generally worked it correctly. One might, for example, assume that one possible scenario is that people either knew how to work it or didn't know how to work it. If you knew how to work it, you could work it. If you didn't know how to work it, you couldn't work it. Maybe that's kind of a simplistic explanation, but that seems to be the case. That would be my speculation on that. Otherwise, there's not much noteworthy here. Going to page 3. The page 3 answers, again, everybody tried to work those first 5 crunchers. 100% of the people worked 100% of the problems. And then when we got to 26, 27, 28, there were fewer people that tried to work it. But if you look down at the bottom, again, for 26 and 27 particularly, most of the people who tried to work it got it right? So while that is on problem, just to be more specific, on problem 26, while it looks like maybe 55 or 60% of the people tried to work it, about 85% of the people who tried to work it got it right. So what that says to me is, I guess, again, I'm extremely reluctant to tell coaches how to coach because I'm completely ill prepared to do so. But basically, what rattles around in my mind looking at this is that maybe if the conclusion I'm tempted to draw is that maybe if students knew how to approach those problems, they could work them correctly. Okay, problem 28, however, is a kind of a different story. In this case, about 50% of the students tried to work it, but I would say probably only about 40% got it correct. So, and problem 28 is really no different from 26 or 27 in my mind. So I think 28, just the look of the draw, maybe was a more difficult problem. Going through to look at the problem 30, again, problem 30, I think was just a hard problem. You have to appreciate problem 29 and 30 in my mind are equivalent in terms of the level of difficulty, but it looks like in terms of the problem, and we can look at problem 30 and see if maybe there's some reason that that students didn't work it correctly. It may be that it called for an obscure formula. So it was a problem that was easy to work if you knew the formula, but if you don't know the formula, it would be impossible. That's my speculation. We can look at problem 30 and see what it is. Maybe I'm asking for a surface area of some complicated object. We can see. But at any rate, problem 30, a lot of people tried it and not many got it right. Again, I think that probably is a problem specific thing, not something that's a test trend. Okay, charging on through, let's go ahead and get through this. Problem page 4, again, the problems. So I'm sort of ignoring the stated, the number crunchers. Problem 36, 37, 38. I would say, the number of people that tried to work it, about that same number fraction got it correct. So there seems to be not much to really say about that one. Problem 39 and 40 are the, if I remember correctly, that's the circle in a triangle or the circle outside a triangle, and the law of sines, law of cosines. Apparently, the way I would interpret these results is that there were a number of people looking at the top curves. There are a number of people that opted not to try to work it, and I think perhaps those were maybe students that maybe weren't as expert with the formulas for the circles and triangles, or with law of sines and law of cosines. But the people that did attempt to work those problems did a very good job of getting it successful. Looking at problem 39, the circle in a triangle problem, looking at the bottom there on 39, 95% of the people that tried to work it got it correctly. And I'd say maybe 90% of the people that tried to work, 90% of the people that tried to work problem 40, the law of sines, law of cosines problem, actually got it right. So again, this would be, I would look at this and say, well, if there was a magical way for all students, all contestants to know those formulas, then maybe all students could do well on those problems. Again, that's my speculation. Okay, going on, looking at these, the just looking at the state and geometry problems, problem 46, I think was just a difficult problem. That's the scaling problem. Again, there were maybe, you can see the number of people that tried to work it was about 35 or 40%, but I would say it looks like fewer than 20% got it correctly. So the people that tried to work it, most of them did not get it right. The same is true for problem 49. Problem 50 was a little easier. Again, problem 49 and 50, at least as I designed the test, they're designed to be of equivalent difficulty. So I think the difference on problem 46, 49, and 50 is that it is just the luck of the draw for the problem, that specific problem. 47, 48, but again, looking at the bottom performance, most of the people who tried to work it got it right. So, and that's the linear regression and the iteration problem. Looking at the page 6, we'll do this and get through this pretty quickly. Problem 57 was apparently a real boner problem. It was a tough one. Not many people tried to work it, and the people that tried to work it, most did not get it correct. So I think I overdid it on problem 57. Problem 60, 58 through 60, I think there's probably not much to say. There were, of the people that, there seems to be sort of a spread in the success rate on working those problems as we go through. Now here's problem page 7. The people who tried to work it, only about 2/3 of the contestants tried to work problem 66 through 70. And again, that's because of making strategic decisions to stop working the test early in problem numbers. Again, on the last page, stated in geometry problems, with the exception of the logarithmic solution, which, by the way, of the 60% of people who tried it, looks like about 85 or 90% got it correct. So again, that's, I would say 62 for those of you that maybe don't teach or how to do those logarithmic solutions. It might be worthwhile. That might be something you might, that you might consider focusing on, because of the students that know how to do it tend to get it correct. At least that's my conclusion. 63, 64, and 65, those are just real hard problems. And again, the trajectory problem, at least the conferences 3A through 6A tended to have varying degrees of success working it. Those who tried to work it got it correctly, right? Whereas the 64 and 65, those were tough problems. Few people tried to work it, and looking at the bottom, few people actually got it correct. So I think maybe I'm getting to overdoing it on those plane geometry problems too. Okay, let's look at one or two other things, and then we'll open it up. We'll hopefully have some time for some discussion. I got about 15 minutes left. Maybe we'll have some time for some questions and answers. This is by conference, what the last problem attempted was. And so what you see here is, if we start with conference 1A, there was one contestant. This is the blue line going from left to right. There's one contestant who stopped. The last problem they tried was problem 35. So they worked the first 4 pages basically. There was another contestant who worked problem 45, which was they worked through page 5 and stopped. But for everybody else, the way I interpret this is there were a large number of people, a significant number of people that stopped at problem 55, you see. And then there were a lot of people that went ahead and worked the whole contest. If you do the math, basically the way I do the math on whether to go to problem 70 or to go to problem 55 and stop is if you were to stop at problem 55, compared to stopping at problem 70, if you decide to go, if you're at problem 55, you decide, should I go on and work to problem 70, which basically means working those last 5 problems on the test, which are the supposedly easy to work number crunchers. Basically, if you work all 5 of those problems correctly, problem 66 through 70, you wind up, you basically have 10 new skip problems, which is minus 20, but you have 5 worked correctly, which is plus 25. So you wind up netting plus 5 points by doing so. So basically making the decision to go from problem 55 to 70 is, if you feel like confident you can work all 5 problems correctly, then you can actually get plus 5 points on the test by doing so. And again, I leave it to you coaches on whether that's a good move or not. However, on the other hand, you work one of those 5 problems incorrectly, you net 0. Well, no, I guess you get 20 correct. Actually, you net minus 2, right? because you have 20 points for the 4 correct ones, 22 points of penalty for the 11 skipped or incorrect problems. So anyway, so I think basically the way I interpret this is strategically contestants are sort of guided to either stop at problem 55 or stop at 70. The tail where some worked 56 and stopped at 56 or 57, I think maybe some of the contestants sort of took a look at 56 and 57. If it looked like they had a reasonable chance of working it correctly, they went ahead and worked it. But many just simply stopped. Okay, the significant digit problems, I'm going to go through this pretty quickly. Basically, there were 2 significant digit problems. These are the stats on problem number 27, where basically what it says is the blue, this again is by conference, the blue bar is the people that worked it correctly. That means they got the right answer and the right number of significant digits. If you jump up to the very top to the yellow or the yellowish color at the very top, those are people who worked the problem correctly, but got the wrong number of significant digits. So it looks like, I look at this, I'd say probably about half got it quote correct, and then about half of the half that got it correct messed up the significant digits. Quite a few people skipped the problem. The gray area are people that just skipped it. And so there were quite a few that just skipped this problem 27. Looking at problem 37, it's a little bit similar. Obviously 37 is a difficult problem. So we see that looking at the blue at the bottom, you see that there were relatively few people that got it correct. That is correct with the right number of significant digits. And that for all practical purposes, there were even not very many people that actually got the answer correct, regardless of doing the significant digit part of the problem. Lots of people skipped it. The gray area, I'd say most of the people just skipped it. There were a few that worked it and got it incorrectly, and that's the orange. So I'd say, judging this, I would conclude 37 was a difficult problem, and not many people got it right. Okay, so here's my analysis. This is, I think, my last slide. This is my run on the test. It looks like, I think it seems to progress pretty well from easy to difficult. I think I did a reasonable job with that. On the more difficult problems, there seemed to be a predictable trend of success from 1A to 6A. That at least that seemed to be the case. The problems the students had trouble with on this test were, again, it's probably, I would say this is predictable. The page 4 stated problems plus problem 61, those are all sort of in a class of their own as being the most difficult problems on the test. The scaling problem was hard, but I don't think it's by nature of it being scaling. I think it was just a hard problem. And then the calculus applications problem was really hard. I think it was also a really hard problem. And you have this high level of knowledge that's needed to do that. People had issues with the trajectory problem as well. Again, those tend to be hard problems as well. And with that, I think I'm at the end of this. I do have the contest, but I think hey, David, I think if it's possible to switch people on, what I was hoping is we could just have a Zoom chat, and I think I'll leave the contest up because if people have questions about a specific contest problem, I can get to it fairly quickly and everyone can see it. So is that okay, David? Could we, at this point, I'll stop talking and we'll open it up for comments, which I'm very anxious to hear what you think about this or for questions.
Yeah, that works. So if you have a question or a comment, feel free to unmute and jump in.
Dr. Bourell?
Hi.
Hi, I'd like to see you work. I believe it was the scaling problem because I'm not seeing it as a scaling problem, but
okay.
46.
Yeah, let me, it's up here, except mine is all muted out by the menu. Let me just do this. Okay, we can get to it here. Yeah, let me, if I could, let me, if I could impose on you to shoot me an email.
No.
I'll be happy to work it for you and send you a solution. But let me just read it and tell you the approach. So it's a brand of containers are made from plastic, all have the same thickness. So they all have the same thickness. What that means is the volume scales with the area. Because if the volume, basically in this case, because the volume is equal to the area times the thickness, because they have the same thickness, the volume doesn't scale with L cubed, it scales with L squared, because the volume is equal basically to a constant proportionality times L squared times thickness. So that's one issue. Then they're designed to hold liquid. So basically it's, if an empty 2-gallon container costs so much, what's the value of a full 10-gallon? So basically what you have to do is you have to assume that the gallons is the volume of the is associated with the size of the container. So so basically the ratio of the 2 gallons, which would be 5, would be proportional to L squared, where L would be, say, the height of the container. So you can solve that out to see what the cost of the container would be, assuming that the cost is proportional to its volume. And then you have to add, since it's a full 10-gallon container, you have to add 10 times. Well, you have to add $107.50 for the contents, right? So basically, that's the way it works. But send me, it should be an email. I'll be happy to send you the solution.
I'm curious, did you look at any of the answers to these? The kids that did answer them, could you tell what they were doing wrong?
I did not do that on this test. Certainly it can be done. I still have all 123 tests and can go back and look and see if there's a common error. Unfortunately, in the compilations that they did, the only information I gathered from the graders was whether it was right or wrong or skipped. But certainly, if it might be worthwhile going back and looking and seeing if there's a common error, and that might be worthwhile doing on all these problems that were really hard. I think that might be a good exercise for me to do, and maybe I can bring that up at the student activities conferences this fall. Maybe talk about that some.
Well, that's probably putting too much work on you, but I've noticed as a grader that most of the time when they get them wrong, they're generally getting the same wrong answer.
Mm-hmm.
So yeah.
Mm-hmm. Sure. Yeah, it's a good point. Yeah, it's not that many problems. I mean, there's just a few problems where people didn't work it, and again, we can see how that goes. Given the silence, by the way, I mean, obviously, if people have a question really about anything, if you want to talk about relative to the contest, I'm happy to talk to you about it. I can prime that pump by telling you that I actually have already drafted all 9 tests for the 2022 contest year. I'm hoping and praying, just like I'm sure all of you are, that it'll be look more like 2019 than 2021. Let me feel free to jump in. Let me just look at problem. We have a few minutes left. Let me look at problem 18. This was one that kind of shocked me a little bit, that it was difficult to work. So this one's Quincy decreases her time to run 1 mile from 9 minutes 38 seconds to 8 minutes 7 seconds. What's the percent increase in distance traveled if she runs 30 minutes at each rate? So I think distance goes as velocity times time. So the velocity changes, but the time is the same. So basically, the way my approach to this was that the change in distance is the reciprocal of the change in time, or maybe it's proportional to the change in time. But basically, just taking the ratio of those times and making sure it's either greater than 1 or less than 1, as the case of the distance, knowing that the faster runner travels further. That it seemed like a fairly straightforward problem. Maybe the percent increase may cause some people some difficulty, but at any rate, that's that problem. Looking at the other one that I think was surprisingly difficult, was it problem 30 that I think was hard? I think it was problem 30 that was hard. And see, it's total surface area of a cylinder. Maybe there were people that had trouble with recalling that the formula for the surface area of a cylinder. So maybe that was the issue there. Again, an attempt to fill the silence. Looking at problem 57. Problem 57 is if you read that problem, it's a really hard problem, because it has to do with transmission of light. So there's kind of a level of physics understanding in terms of light and how light transmits through media. Again, it's not complicated by the index of refraction directly, but we're talking about absorption of light as it goes through. It's varying, and that's an exponential decay of intensity as it travels through a medium. So I think this is a pretty tough problem. So it's not surprising that not many people got it. If looking at problem 58, problem 58 is basically doing matrix multiplication with the two 2x2s. And again, to reiterate my first rule of learning, which is everything's easy if you know how to do it. I look at this and go, asking for F12, that's basically, this is a very straightforward problem. Basically it's F12 is 894 times 36 plus 838 times negative 67. I mean, it's two pairs of numbers multiplied together and added gets you the answer. So again, it's a little bit surprising to me that that more people didn't get that. On the other hand, exactly the opposite happened with 59. Now that's a solid of revolution, which is probably the hardest problem I could put on 59. And I'm really kind of surprised, frankly, that as many people got it correctly as they did. Again, it's a straightforward integration, but you have to know that solid of revolution formulas. There's two of them that are not particularly trivial that have to be memorized, I think, to work that problem successfully. But there were a number of people that obviously have done that. Anyway, I think I'm out of time, David. So I don't know if there are any other questions. I guess I'm happy to try and address one more. Otherwise, I guess we can close the session.
So yes, we did have one question in the chat box about the pre-recorded sessions, that many of those were made last year. And yes, that content is still going to be applicable in the STEM events. Generally, there are some other contest areas, of course, that change source material and so forth year to year. But yeah, we tried to just repost sessions that would definitely still be applicable this year and going forward. And we do. It is our plan and expectation that we will be back to a much more normal calendar and schedule and format of events this year. So unless something changes or something unexpected comes up, but that is the plan, that we'll be back to in-person contests in the spring, as well as student activities conferences in the fall. Recordings of today's session, as well as the other STEM sessions that have happened this week, should be going up over the next few days on that same UIL Conferences YouTube channel. I don't know exactly when that'll be posted, but I would say by early to mid next week they should be available there. All right, if there are no further questions, thank you, Dr. Bourell, for a great session. Thank you, everyone, for attending. And we hope you have a great and restful summer break, and we look forward to seeing you back at in-person UIL events in the coming school year.